Hello and welcome to Hacker Heap. In this video, we will solve the problem longest duplicate substrings. So before we start, please do like and subscribe to the channel Hacker Heap. So let's look into the problem. Given a string S, consider all duplicate substrings, contiguous substrings of S that occur 2 or more times. Return any duplicated substrings that has the longest possible length. If S does not have a duplicated substring, the answer is null. So let's look into the given example. It has B, A, N, A, N, A. We see this A and A repeated twice. So we are returning A and A. Let's say if there is an NA, how it looks is we have AN, AN and AN, AN. So we will return 4. Or let's see if there is one more. AN, ANA, which is of length 5, AN, ANA of length 5. So actually, if the string is BANA, NA, NA, the substring of the maximum length is ANA, NA. So how do we find it? So this is not something I come up. If you look into the hints, hint number 2, this is use Rabin-Karp's algorithm. So what is a Rabin-Karp algorithm? Rabin-Karp algorithm is used to find duplicate substrings, and there are 2 patterns. And for this problem, we need to use the multi-pattern search. So we will implement this actual function in Java. This is in Python. Let's see how actually Rabin-Karp algorithm works. So let's say your given string is A, B, C, D, E. Generally, if you want to see if there are any duplicated strings, you need to loop through each element. Okay, let's say if there is any A. Okay, there is a substring of length 1. And now we will look into this and see if there is another substring AB at the end. You have to do that for every length. So it becomes very problematic. So what Rabin-Karp's algorithm does is, okay, let's assign a value for each alphabet. So for A, it will be 1, 2, 3, 4, 5, 6. For F, let's say the given string is B, A, A, B, A. So let's say the given string is this. Now we know we need to return A, B, A, right? So how do we know? So since the value of A is 1 and B is 2 and A is 1, the length of this is 4. We will check if there is any substring of length 3 with the total 4. Now that creates a problem when you come here where it is BAA, even length is equal to 4. We don't want to have those duplicates. Let's see one more example where it says A, B, C and D, A, A. If you see the length of it, 1 plus 2 plus 3 is equal to 6 and D is 4, 1, 1 is 6. But these substrings are not equal. So what we need to do is we need to create a complex hash function, and we also need to check for the repeated values in the string. To avoid this superset situation where it has the same length, we will need to create a hash function. So how do we do it? Instead of assigning values based on just the alphabets, what we will do is for a given string, let's say banana, for the given string banana, what we will do is we will read through it and we will assign a value for the first index as 1, second index as 2, and we will compare it with the alphabet value so that we don't get those supersets. And A, these will have this A and this A won't have the same value. So we know it's not the same. So what we need to do is for a given string banana, we will create values for each index and each variable, for each character, so that they are different from each other. And when it comes to A and A, we will make sure it's an A and A. Instead of having duplicates, we will have an array of the same length, integer array, and we will fill it with the desired value of this. We will see how we will fill those values, but we will have that array. And we will have a rolling hash value because there are 26 alphabets. We will assign as 26, and there can be a scenario where if the given string is so long, you might go out of index for an integer value. So we will have a modulus which would be like math 2 power 32, because integer holds like 32-bit variables, 32-bit values. So we will use that. Once we had this, we will loop through like each element with each length, and we will call this function Robin Carp function, which will check if this particular hash function, we will have a hash function there. We will get the hash function from here and see how they are doing it, and we will implement the same hash function here, and we will maintain a set to store hash values, and we will see every time if there is a hash value that's already exists in the set, we would return that string. Else we will, once we are out of the loop, what we'll do is we will return -1. And here we won't be sending it for each and every digit. So if you look into the second hint here, it says use a binary search. So that's what we will do. We will use a binary search. So we will make sure we won't send the whole string. First we will check with half of the string. If we don't find any substrings, we don't want to do the whole string. So we will move the pointer from here to here, or here the right from here to here. We will see how it works. So let's go ahead and code that out. So first we'll find the length of the string. It's total length. Now we create an array called nums, which will hold the value of each particular string. Int of length. Now how do we fill this array? For each index, nums of I would be integer of s dot caret of I minus int a. So I'm trying to create a value for each index element by removing that element from the a, so that it gives me the value, integer value. So if it's the character is a, it would be 0, character is b, it would be 2, it would be 1, and character c, it would be 2, and so on. So that's how we do it. So now once we set that, we need to create a variable for rolling hash value. We will set that to 26 because there are 26 characters. And to maintain the overflow, let's say if the string is too big, then the hash function might be too big. So we will also create a modulus which we can divide by, just to not have the overflow of it. And since integer holds 32-bit value, so we will do math.pow of 2, 32. Now we have all this. We will have L. This is basically the mid value. Now we will have left. As I said, we will do a binary search. We don't want to perform for each digit. We will check if there is a substring that is included in the left side of the given string or the right side of the given string, so that we don't have to go in order of n. So we are reducing the time complexity of going digit by digit to O of log n instead of order of n. This will be 1, and int right is length. Okay. While left not equal to right, what we need to do is we find the mid. Mid is equal to, again here to avoid overflow, what I am doing is right minus left plus 1 by 2, or I can just do right minus left by 2 just to avoid any overflow. We will check if there is any substring, like search for the substring. What we need to pass are the mid value, the rolling hash, the modulus, and the numbers, the values of the strings, and what else? And the length of the string. If is not equal to -1, where we will be returning -1 if there is no substring duplicate string, then what I'm doing is left is equal to mid plus 1, else right is equal to mid, like we do in any binary search. Once we are out of the loop, we will again do one more search with left minus 1 a comma mod comma nums comma length. We'll store the value as int start. So why we are doing it is, so we need to return the largest duplicate string, right? We need to know the start index and the end index. This will give us the start index, and we will see how we will get that. If start is not equal to -1, let's say if there is no duplicate string, all we are returning what we should return, we would just return this, or we need to return the substring of start comma start plus left minus 1. So yeah, now we need to finish this search function. For search function, all we need to do is copy the Rabin-Karp's algorithm. Let me go ahead and write that out. We are actually sending the index back. Int length. That's all we got. We will define a hash value. We will generate the hash value for each string to this. As I said, we will have an hash set which stores long values, which if we have already seen that particular hash function. Now we will generate the initial hash value using for int I is equal to 0, I less than mid nums of I modulus mod value. So this will give us a default hash value, and we will add this hash value, add of hash value. So what we are doing is we created the hash value for the given string, the whole string, substring from 0 to mid. We created a hash function, and we said that we have already seen that string. Now we will go through each of the, now we also need to create one more rolling hash value like we created earlier. So we will define an AL. Again, we will do the same thing for int I is equal to 1, I less than or equal to mid, I plus plus, AL is equal to AL star, given A, modulus of mod. Now we will get into the real function. So we are just implementing this Rabin-Karp algorithm where we had the mid value, we will have the string and set of the string. But if you see, we created this set inside our function instead of passing it all the time. So now we will go through each value of the digit. For int start is equal to 1, start less than length minus mid plus 1, I start plus plus. So now what we are doing is, here we calculated the hash function for the substring starting from 0 to mid. Now what we are doing is we are calculating the hash function starting from index 1 to mid plus 1. H is equal to, we will implement the same thing, H star A minus nums of start minus 1 star A modulus mod plus mod plus mod. So you can try any hash function that creates unique values for each substring. So this is the hash function. I got it from somewhere else. It's not something I wrote. So you just remember this hash function is pretty much used for a 32-bit integer values where it generates a unique hash function. So remember this hash function. H is equal to H plus nums of start plus L minus 1 modulus mod. So yeah, if scene dot contains of H, you would just return start the index of it, else we will add scene dot add of H. Once we are out of this loop, we will return -1 if we didn't find it. So let's walk through what we have done here quickly. So we got the string banana. So we created an array of length of banana, 1, 2, 3, 4, 5, 6. So we filled the values for each value. Let's say this is 1, 0, some 5, 0, 0, 5, 0. I'm sorry, I said earlier we won't be populating with the same value, but we will be populating with the same value. And we took the rolling hash function just to make sure we don't get the same value all the time. And we created the mod because we are using an integer. We had a mid, left and right. So we calculated the mid. Now, once we call the search function, what we are doing is, let's say the mid is this, B-A-N-A, right? So once I am here, what I'm doing is I created a hash value based on the length. So I created an hash value from B-A-N-A to the mid, which let's say gave me some 100 or something like that. And we added that to the set, added 100 to the set. Now what we are doing is I'm calculating the hash function. So if you see here, what we are doing is we are taking the index of the, we are also taking index into consideration so that we don't get duplicate values for banana and anana or A-N-A-B. For this and this, we don't want to create a same hash value. That is the reason we are taking index into consideration and we are applying all this modulus. So we had one internal modulus not to overflow anything. Now we created a hash function. We are checking if the hash function is there, we would return that index. So if you see here, every time we did that, once we are out of the loop, we will do again one more search from left -1 and mod. We will give the index. Let's say the start index in this case would be this 1 and return 1, and we are returning the substring of start, and start plus left -1, which would be this value. So we are returning this Anna. So remember this modulus function. I haven't written this modulus function. You can come up with your own stuff. I'm not that smart, so I copied it from Robin Karp algorithm and somewhere else where people have used it and created a unique hash function. So try yourself and I hope this helps. I try to explain it properly. It's a hard problem and it's very hard to explain the Robin Karp algorithm here. So I hope I tried my best. Let's go ahead and run this and see how it looks. Already an error. Incompatible types math.power of 2, 3 or double to int. Okay. I know what's happening here. What did I do? Line 47. Oh, my bad. Sorry. Damn it. If it is not equal to -1, I need to return substring, not the colon. Yep. Yeah, it worked. Please do go through the problem again. I know it's very hard for me to explain. So this modulus function, you can come up with whatever function you want. The whole idea is we are trying to find an hash function and we will create an hash value. Instead of looking for each character, we will just check for the hash value if it's there or not. If it's there, yes, we hit a substring, duplicate substring, and eventually we will check the longest duplicate substring and just return it. It's an hard problem, so don't stress yourself if you didn't come up with solution. I just copied this hash function from somewhere, I admit that, but yeah, please do try to come up with your own if you can. Thank you for watching. Please do like and subscribe to the channel Hacker Heap. Thank you.